fifth grade. We're going to start Module 3, Lesson 5 today. And the big difference for today is that we're no longer subtracting fractions. We're no longer adding fractions. We're going to be subtracting fractions. But the process is very, very similar to the past couple of lessons. So if you were doing well with the picture models, you should continue to do well with the models for subtracting. And I think it's actually a little bit easier too. So let's go ahead and get started with the first one. For this first one, I want you to just follow along with what I am doing, and just make sure that you're making your boxes big enough so that you can easily do the work that we need to do for these problems. So our first one is a half minus 1/3. And just like always, I will start by drawing a model for each of the boxes. And then I will show you 1/2 on this one. So I always start with that vertical line. So I cut this box in half and I shade it in just like that. So just like before. And then for my third, I will again start with having my second box with horizontal lines. And then I just fill in one of those boxes. Now, just like when you are subtracting, or just like when you're adding fractions, and you need to have common denominators, when you are subtracting fractions, you also need to have common denominators. So if this box was cut into thirds, I also need to cut this box into thirds. So I'll do that right now. So I'll have my horizontal lines right there. And then I will cut this box in half so that both of my models now match, and they both now have a common denominator. They look the same. So now I'm going to write my new fraction. This is where it's very important that you follow along, because this is where it's going to get a little bit different after we get our equivalent fractions. So this model right here shows me that I have 1, 2, 3 boxes shaded in. So I have 3 out of a total of 6. So I have 3, 6 minus 1, 2, 2, 6. Now, yes, you can just do the math up here. So you would have 3 minus 2, which is 1, 6. And that would be your final answer. But I also want to show you what that would look like in the model. So what I'm going to do is I'm going to take a different colored marker. And what I'm going to look at is that I'm basically subtracting this 3, 6 model from the 2, 6 model. So 3, 6 minus 2, 6. And since I have 2 boxes right here, what I'm going to do is on this model, I'm going to cross out 2 boxes because there's 2 right here. So for this one, I'll cross out 2 boxes. So I'll do this 1, 2. You don't have to do anything to this box. This box is just here to show you how much you are subtracting. And right here, I will just count then the number of boxes that are still shaded in without being crossed off. And that is just 1 out of my 6 total boxes. These being crossed out does not make it so that these boxes don't exist anymore. It just means that those were subtracted because of this. So I have 1/6 left. So I have 1 shaded in box out of 6 total boxes. So you're going to be doing both ways, where you're going to show me in your model how the subtraction works, and then you'll also be doing it, we'll call it numerically with the numbers. So let's take a look at the next problem. Again, you can follow along with me on this one. So I have 1/3 minus 1/4. So just like always, I'll show my model for a thirds and then a fourth. So I cut this one into thirds, and then I'll cut this one into fourths. And then I just need to make sure that I shade in each part. So I have 1/3, so that means I shade in 1 box. And I have 1/4, so I shade in 1 of my 4 pieces. Now, just like always, I just need to make both of these boxes look like each other, so I have common denominators. So since I cut this one into fourths, I cut this one into fourths. 1, 2, 3, fourths, so that it's cut into fourths. And then I'm used to cut this one into thirds. So 1. So I now have identical boxes. And now, just like last time, I'll write my new fractions. So now I have 1, 2, 3, 4 out of 1, 2, 3, 1, 2, 3, 4. So 3 times 4 is 12. So I have 4 12s minus 1, 2, 3, 3 12s. These denominators should always be the same. If they're not, then you cannot start subtracting. So now that I have 4 12ths minus 3 12ths, I can start by doing it numerically. So I know that 4 minus 3 is 1. And just like when you're adding your denominators will still stay the same. So this will just be 1 12th. Now to show that on my model, what I can think about is that, okay, so this is 4 12ths and this is 3 12ths right here. I have 1, 2, 3 boxes here. So that means that I'm going to cross off 1, 2, 3 boxes in this model. Remember, I don't touch this model. This just tells me how much I need to get rid of or cross out. So with my different colored marker, I'll cross off 3 boxes. So I have 1, 2, 3, and this is why you want to make your models big enough so that you can cross off your boxes and still see what you have left over. And when I cross off those boxes, I can see that I only have 1 shaded box left over, so that's 1 out of a total of 12 boxes. So my answer of 1/12 is correct. For this next part, I would like you to try this problem on your own after I have it written on the boards. And just think about what we've written so far. I would like you to do it numerically and then also with the pictures by crossing out the boxes. So I have a half minus a fifth, and I'm going to draw the model for the half and the model for the fifth. Remember, I want you to pause the video, try this one on your own, and then come back together. So for my half, I'll cut this in half, shade that in, and then for my fifth, I'll cut this into fifths, and I'll shade it in like so. So I have my half and I have my fifth. Now remember, I need to have those common denominators, so since I cut this into fifths, I'll cut this one into fifths, and then I'll cut this one in half. Just like last time, I'll show my equivalent fraction. So I have 1, 2, 3, 4, 5 tenths, because I have a total of 10 boxes. 2 by 5 is 10. Subtract 2 tenths. And so numerically, I would say that I have 5 minus 2, which is 3. And my denominator will stay the same, so I have 3 tenths. Now I can show you this in picture form as well, because remember this is 5 tenths minus 2 tenths right here. So I know I have 2 boxes filled in, so that means I can cross off 2 boxes from my model, which I'll do in a different color marker. So I have 1, 2, and then I just count the amount of boxes I have left over. So I have 1, 2, 3. That will be my new numerator. And then I still have a total of 10 boxes. So my denominator stays the same, and again, I got my answer of 3 tenths. So let's take a look at problem 3 now. And we're just going to continue doing this model and the numerical process. It's just that eventually our models are going to get a little bit bigger from what we've been used to. So now I have 2 thirds minus 1/4. So I'll draw my model for 2 thirds. I'll draw my model for 1/4. Make sure you pause the video, try this one on your own, and then come back together with me. So 2 thirds, I will cut this model into thirds. And then remember, since there's that 2 there, that means I have to fill in 2 of my parts. So 2 like that. And now I have to show you a 4. So I cut this into 4. And I'll shade in my 4th right here. Now, just like before, I just make sure these have common denominators. So if this one's cut into 4ths, I'll cut this one into 4ths as well. 4. And then since this one was cut into thirds, I need to cut this model into thirds. So I'll do that like so. Now I need to make up my new equivalent fraction. So numerically, I'll start that process. So I have 1, 2, 3, 4, 5, 6, 7, 8, 12. I know I have 12 because there's 3 going across and then 4 going down. 3 times 4 is 12. And then I'm subtracting 1, 2, 3 12ths as well. And now I have 8/12 minus 3/12. I know that I just subtract my numerator, so 8 minus 3 is 5. My denominator will stay the same, so I have 5/12. To show that in my model, all I'll do is I'll show you that 8/12 minus 3/12. Since I have 1, 2, 3 boxes here, I'm going to be crossing off 5 boxes. So I'll come over here, I have 1, 2, 3, 4, 5. I find it easier if I just kind of go straight down and then jump up to the next row if I need to. You can go back and forth if you prefer that way. However you do it, just make sure that you have 5 boxes crossed off. Then I count the amount of boxes that are left over. So I have 1, 2, 3. Those are boxes that were not crossed off. And there is still a total of 12 boxes in my model. So my answer is still, oh, just kidding. I miscounted. Oh, I thought, oh no. So this is supposed to be 5/12 because I have 1, 2, 3, 4, 5. I was only supposed to cross off 3 boxes. So my answer is 5/12. So a little oopsie. But that is how you would do this problem right here. Remember, if you have any questions, please make sure you're asking for help. And don't forget that this side, you don't do anything to this. This just tells you how many boxes you crossed off. Let's move on to problem 4, which is 1/2 minus 2/7. 1/2 minus 2/7. I'll draw my model for my 1/2. This is one where you might want to draw slightly bigger boxes than you usually do because you are going to be cutting it into 7ths. So we'll start by drawing the model for the 1/2. Make sure you pause the video and try this problem out on your own before you go watching what I've done. And then this model needs to be cut into 7ths. 1, 2, 3, 4, 5, 6. And I have to color in 2 of those pieces to show 2 7ths. So we have that there. Now I need both of these models to match because they do not yet. So since this one was cut into 7ths, this one needs to be cut into 7ths. 1, 2, 3, 4, 5, 6. And since this one was cut in half, I need to cut this one in half. And now I just need to make my new equivalent fraction. So I have 1, 2, 3, 4, 5, 6, 7 out of 14, because I know that 7 times 2 is 14. So I have 7/14 minus 1, 2, 3, 4 14, because I know that my denominator is going to stay the same. So I have 4/14. 7 minus 4 is 3. My denominator will stay the same. And my final answer is 3/14. Now, if I was doing this with my picture, I'll see that I have 1, 2, 3, 4 boxes on this side. So I will cross off my other color marker 4 boxes. 1, 2, 3, and 4. And I'm left with 1, 2, 3 boxes left out of a total of 14 boxes. And my final answer is 3/14. We're going to move on to our very last problem, which is 4/5 minus 2/3. And then you'll be able to move on to the problem sets and homework sets. So 4/5 minus 2/3. Again, this is the kind of problem where you might want to make a bigger model just because you're going to be making fairly large models for this one. So for this one, I have 4/5. So I want to cut this into 5ths. And then remember, if this numerator is 4, that means you need to shade in 4 of these parts. So shade in 4. And then for this one over here, since this is in thirds, I need to cut it into thirds. And since I have that 2 on the top, I need to shade in 2 of those pieces. Now I need both of these to look like the other. So I'll cut this one into thirds going this way, and I'll cut this one into 5ths like so. And now I'll find what my new equivalent fractions are. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 15 because I know that I have 5 going across and 3 going down. So 5 times 3 is 15. And I will subtract 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 15ths. And then I will go ahead and subtract 12 minus 10, which is 2, out of 15, or 2 over 15. And I can also show that using my model as well, because I know that I have 10 boxes right here. So I can cross off in this first model 10 of those boxes. So show that. I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I have 2 boxes left over, and that is out of a total of 15. And you might get frustrated having to do with these models, but it is a good way to check if your numerical work is correct, because you're probably more likely to make mistakes up here than you are with like just crossing off boxes. So if you use the numerical model and then you use the picture model, it helps out a lot to see if you make any mistakes, because you can compare your 2 answers then and see if you went wrong anywhere. So let me pause this real quick, and I'm going to go get your homework set and problem set. All right, 5th grade. So for your problem set, you're doing pretty much just like you've been doing for the past few lessons. You're going to do 1 A through F, so a total of 6 problems, and then word problem number 2. Remember, word problems are not as bad as you think they are. You're basically just subtracting fractions. You just have to figure out which fractions you're supposed to be subtracting. Then for your homework tonight, this is where it gets a little bit different, but not too much. You're going to be skipping number 1. You're going to move on to number 2, which is basically just like the problems from the problem sets. So you're going to do number 2, A through F, so a total of 6 problems, and then word problem number 3. Remember, if you have any questions, please make sure you ask, and then you can also watch this video later on at home if you need to. So good luck on that, and have fun.